Here we are given an equation for the mileage of a certain gas. Here we are given the gas mileage equation for a certain vehicle, where x is the speed, and we want to find the speed at which the car gets 30 miles per gallon. That is the mileage. So 30 is going to be equal to negative 0.04x squared plus 3.6x minus 49. Okay, we want to first get a positive x squared term. So I'm going to bring everything to the left. Rewrite that as a positive 0.04x squared, a negative 3.6x, and when I add 49 to each side, I'm going to have plus 79 now equals 0. This will become our first line of the problem. I don't think any of us like the decimals, so we will multiply through by 100 as we need to, inserting zeros as we go, and this will give us 4x squared minus 360x plus 7,900 equals 0. We see a lot of even numbers, and it turns out that 4 goes into all three terms, so let's factor a 4 out. This leaves us x squared minus 90x plus 1,975 is equal to 0. Now, that is not a problem I'd like to factor, and when I go back to the problem and I see that they're asking me to round to the nearest mile per hour, that tells me it's probably not going to be a clean answer, and that I'm going to want to use the quadratic formula. Now, I'm going to ignore the 4 out front and use 1, negative 90, and 1975 as my values of a, b, and c for the purposes of the quadratic formula. When I look at the discriminant b squared minus 4ac, I'm going to have negative 90 squared minus 4 times 1 times 1975. This gives us 8,100 minus 7,900, which subtracts to 200. Continuing on, x will equal negative b plus or minus the square root of 200 all over 2a. X will equal negative of negative 90, so that's 90 plus or minus the square root of 200. Now you can leave that as square root of 200 or rewrite that as 10 root 2, your choice, all over 2a. 2 times 1 is 2. I'm going to go one step further. I can notice that both the numerator and denominator can be divided by 2, which will then cancel with the 2. So I'm going to rewrite this as 45 plus or minus 5 root 2. Well, we need an approximation here, rounded to the nearest mile per hour. So we have two choices, add or subtract. If we add, we find out that x is approximately 52 miles per hour, and if we subtract, we find out that x is approximately 38 miles per hour. Now I had to use a calculator to get to those two values. Okay, let's take a moment and look at this problem. In a classic Seinfeld episode, Jerry tosses a loaf of bread, a marble rye, straight upward to his friend George, who's leaning out of a third-story window. Okay, that's just a scenario. We don't need that for this problem. If the loaf of bread leaves Jerry's hand at a height of 1 meter, that's probably because his hands or shoulders about a meter off the ground, with an initial velocity of 18 meters per second, write an equation for the vertical position of the bread, s, so s will be our vertical position in meters, t seconds after release. Use this model. Now this is a formula that usually we see in physics. S is a letter we use for distance. G is going to be the acceleration due to gravity, and it turns out that G is going to equal 9.8 meters per second squared. V subscript 0 is the velocity at time 0, sometimes known as the initial velocity. And s sub 0 is the distance at time 0, sometimes known as the initial distance. Those are the clues that we need to start this problem off. We're being asked to write an equation for s. This will become s equals negative 1/2 times 9.8 t squared plus v0. That's our initial velocity, which we were told is 18 meters per second. So 18t plus an initial height of 1. Let's just clean this up one little bit. S is equal to negative 4.9 t squared plus 18t plus 1. Now, in part B, they're going to ask us to use this equation. So let's rewrite this really quick. S is equal to negative 4.9 t squared plus 18t plus 1. How long will it take the bread to reach George if he catches the bread on the way up at a height of 16 meters? Okay, on a way up, I'm looking at this as a parabola opening downward, and I see the loaf of bread going up and then coming down. And so if it's on the way up, that means we want the first solution, not the second solution. So here we go. 16 meters is the height. That will be our S, equals negative 4.9 t squared plus 18t plus 1. I would like a positive leading coefficient here, although I don't think that's necessary, but I'm going to, and bring everything to the left. 4.9 t squared minus 18t plus 15 is equal to 0. Since we're going to be rounding, it only makes sense that we're going to be using the quadratic formula for this problem. So let's just focus on the discriminant for starts. b squared minus 4ac. That becomes negative 18 squared minus 4 times 4.9 times 15. 18 squared is 324, and I know we will be subtracting 294 because I've done this on a calculator already, and that gives us 30 for the value of the discriminant. Continuing on, we're going to have t is equal to negative b plus or minus the square root of 30 all over 2a. T is going to equal negative of negative 18, which is 18, plus or minus the square root of 30 all over 9.8. This becomes a calculator exercise at this point, and we find out that t is approximately 1.3 seconds or 2.4 seconds. But because we want the first answer as the bread is on its way up, we are going to go with the solution 1.3 seconds.